A signal came from deep space that should not exist. It was not random noise. It was not a glitch. It was something real, something repeating, something that does not fit the rules scientists trust. And the most unsettling part is this: the more they study it, the less it makes sense. This signal arrived from a region of the universe where there should be almost nothing happening. A cold, distant part of space. A place where stars have already died, where energy is scarce, where silence is expected. For decades, scientists have pointed powerful instruments toward these empty regions, not expecting surprises, but searching for patterns, background radiation, or faint echoes of the early universe. Instead, they found something active, something structured, something that pulses with energy in a way that challenges everything we thought we understood. At first, it looked like a familiar phenomenon. Scientists are used to strange signals. Pulsars, for example, send out regular bursts like cosmic lighthouses. Fast radio bursts appear suddenly and vanish just as quickly. Quasars shine with extreme brightness from the centers of distant galaxies. The universe is full of powerful and sometimes violent events, but this was different. The pattern did not match any known object. The timing was wrong. The energy profile was inconsistent with known sources. And most importantly, it came from a place where none of these objects should exist. This is where the story becomes unsettling, because when scientists tried to explain it, every answer created more problems. Some thought it might be a rare type of neutron star behaving in an unusual way. But the signal did not weaken as expected. Others suggested it could be linked to a black hole. But the rhythm of the signal did not match any known black hole activity. Even the possibility of interference from Earth was tested and ruled out again and again. Everything pointed to one conclusion: the signal was real, and it did not belong. This is not just another strange space event. This is a direct challenge to the models that explain how the universe works. Models that have been built over decades. Models that predict how matter behaves, how energy moves, how space itself evolves over time. When something breaks those models, scientists pay attention, because it means one of two things. Either the observation is wrong, or the understanding is incomplete, and in this case, the data keeps holding up. That is what makes this discovery so powerful. It forces a deeper question, not just what the signal is, but whether the universe is more complex than we believed. Physicists like Brian Greene have spent years explaining that our picture of reality is still unfinished. The laws we use work extremely well, but only within certain limits. Beyond those limits, things begin to break down. Space and time behave differently. Energy does not always follow the rules we expect. This signal may be one of those moments. A crack in the system, a clue that something deeper is waiting to be understood. There is another detail that makes this even more mysterious. The signal repeats, not randomly, not chaotically, but in a pattern that suggests structure, almost like a process, something that starts, stops, and then starts again. This repetition rules out many one-time cosmic events like explosions or collisions. It suggests something stable, something ongoing. And that raises a dangerous possibility. There may be objects or processes in the universe that we have never seen before. Not because they are rare, but because we did not know how to detect them. Until now. This changes the way scientists look at the sky. It means that what we once called empty space might not be empty at all. It might be active in ways that are invisible most of the time. Hidden behind limits in our instruments or gaps in our theories. For years, the assumption was simple. If something existed out there, we would eventually detect it and explain it. But this signal breaks that confidence because we have detected it and we still cannot explain it. That is the part most people do not realize. Science is not just about answers. It is about questions that refuse to go away. And the most important discoveries often begin as anomalies, small inconsistencies, signals that do not fit, data that looks wrong until it is confirmed again and again. This is one of those moments. A signal that forces scientists to question their assumptions. A signal that suggests the universe may still be hiding fundamental secrets. And that leads to the central question of this video. What could possibly create a signal that should not exist? Is it a new kind of astrophysical object, a completely unknown physical process, or something even more radical that changes how we understand reality itself? By the end of this video, you will understand exactly what was detected, why it is so difficult to explain, and what it could mean for the future of physics, because this is not just a story about a strange signal. This is a story about the limits of human knowledge and what happens when those limits are pushed. Welcome to the channel. If you want to explore the deepest mysteries of space and reality, make sure you subscribe. The signal did not arrive as a single burst. It came in pulses, clean, repeating, structured. At first glance, it looked almost artificial in its precision. The timing between each pulse was not perfectly regular, but it followed a pattern that was far too organized to be random noise. Each burst carried a strong concentration of radio energy, far stronger than what is usually detected from such distant regions of space. That was the first warning sign. Signals from deep space usually fade. They stretch and weaken as they travel across billions of light years. By the time they reach Earth, they are often barely detectable. But this one stood out clearly above the background. It cut through the noise like a beacon. The energy profile made it even stranger. Instead of spreading evenly across frequencies, the signal showed sharp peaks. It concentrated energy in very specific ranges. That is unusual for natural sources. Most cosmic events produce wide, messy spectra. This signal looked controlled, focused. Then came the timing. Pulsars are known for their steady rhythm. They spin rapidly and send out beams like cosmic clocks. Some are so precise that they rival atomic clocks on Earth. But this signal did not behave like a pulsar. Its intervals shifted slightly, not randomly, but enough to break the strict regularity expected from a rotating neutron star. Quasars are even more powerful, driven by supermassive black holes. They can outshine entire galaxies, but they do not produce short, repeating pulses like this. Their emissions are chaotic and continuous, not clean and discrete. Fast radio bursts were another possibility. These are extremely powerful flashes that last only milliseconds. For years, they were one of the biggest mysteries in astronomy, but most of them occur once and never repeat. Even the repeating ones do not show this kind of stable pattern over time. This signal did something different. It returned again and again, with enough consistency to be tracked, enough variation to remain unexplained. Researchers quickly realized they were not looking at a known category of object. This was something outside the standard list, something that did not fit the templates stored in decades of astronomical data. There was also the question of distance. By analyzing how the signal was dispersed as it traveled through space, scientists could estimate how far it had come. The result was staggering. The signal originated billions of light years away. That means it began its journey long before Earth looked the way it does today, long before humans existed. It is a message from the deep past of the universe, and it has survived an incredible journey. Along the way, it passed through clouds of gas, magnetic fields, and the expanding fabric of space itself. Each of these should distort or weaken the signal, yet its structure remained intact enough to be recognized. That suggests something important. The original source must be extremely powerful, far more powerful than most objects in that region should be capable of producing. Another detail made scientists pause. The environment where the signal came from appears unusually quiet. There are no clear signs of active galaxies nearby, no obvious sources of intense radiation. It is the kind of place astronomers describe as dead or inactive, and yet from that silence, something is speaking, something that sends out bursts of energy strong enough to cross the universe. something that follows a pattern that feels almost deliberate. That combination is what made this discovery impossible to ignore. It was not just strange, it was out of place. The discovery did not happen in a dramatic flash. It began quietly inside a stream of data. Modern radio telescopes do not work like traditional telescopes. They do not capture images in the way most people expect. They listen constantly. They scan the sky for faint whispers of energy, collecting enormous amounts of information every second. The data is so vast that no human could go through it manually. So machines do the first pass. Advanced algorithms scan through the noise. They look for patterns, spikes, and anything that stands out from the background. Most of what they detect is useless. Random interference, signals from Earth, satellite transmissions. Even microwave ovens can leave traces in radio data. Filtering all of that is one of the hardest parts of modern astronomy. Scientists build complex systems to remove these false signals. They compare data from different locations. They check frequency ranges. They analyze timing. A real cosmic signal behaves in a very specific way as it travels through space. It stretches. It disperses. It shows a signature that tells researchers it came from far beyond Earth. This signal passed those tests. At first, it appeared as a small anomaly, a brief spike that did not match the surrounding data. That alone was not unusual. These spikes appear often and are usually ignored after quick verification. But this one returned. The system flagged it again. Same region of the sky. Similar structure. That is when researchers took a closer look. They began to isolate the signal. They removed known sources of interference. They cross-checked it with other observations. They compared it with data from different times and different instruments. Each time, the result was the same. The signal was still there. It was not coming from Earth. It was not a technical error. It was something real, arriving from deep space. To confirm this, scientists used a method called dispersion measurement. As radio waves travel through space, they pass through clouds of charged particles. Lower frequencies slow down more than higher ones. This creates a delay pattern that can be measured. That pattern acts like a fingerprint of distance. This signal showed a clear dispersion signature, and it pointed to an origin billions of light years away. That eliminated almost every local explanation. The next step was repetition. Many strange signals appear once and never return. Those are difficult to study. But this one repeated. That allowed scientists to track it over time, to predict when it might appear again, to aim instruments directly at it. Each new detection added more confidence. Different observatories confirmed it independently. Different systems picked it up using separate methods. This removed the possibility of a single instrument malfunction. It also ruled out most forms of human-made interference. At this point, the situation changed. What started as a minor anomaly became a confirmed phenomenon. There was a moment when the data became impossible to dismiss, not because of one observation, but because of consistency. The signal behaved the same way across multiple detections. It followed a pattern. It held its structure. It resisted every attempt to explain it as noise. That is when scientists realized they were not dealing with a known category. This was not just another signal to classify. This was something new. And once that realization set in, the focus shifted from detection to understanding. Because finding the signal was only the beginning. Explaining it would be far more difficult. At this point, the problem became clear. The signal did not just lack an explanation. It resisted every explanation that scientists tried to apply. Modern physics is built on patterns. Every known object in the universe follows rules. Stars form, burn, and die in predictable ways. Neutron stars spin and emit radiation with precise timing. Black holes consume matter and release energy through well-understood processes. Even the most extreme events still fit. Inside a framework, this signal did not. The energy alone raised questions. To produce a signal strong enough to travel billions of light years and still arrive with such clarity, the source must release an enormous amount of energy. But the pattern of that energy did not match any known mechanism. It was too focused, too controlled. It lacked the chaotic spread that usually comes with powerful cosmic events. Then there was the repetition. Repetition suggests stability. It suggests a system that can sustain itself over time. Pulsars do this through rotation. Their beams sweep across space like clockwork, but those signals are highly regular. This signal shifted slightly between pulses. Not enough to be random, but enough to break the rules of a rotating object. That small inconsistency creates a major problem. It means the source is not behaving like a simple physical system. Black holes were also considered. They are among the most powerful objects in the universe. They can produce jets of energy that stretch across entire galaxies, but those emissions are continuous or highly chaotic. They do not produce clean, repeating bursts like this. Even more puzzling is the location. The signal comes from a region that appears quiet. There are no clear signs of massive stars, active galaxies, or dense clusters. It is the kind of place where energy should be low, where activity should be minimal. According to current models, there is no obvious engine there capable of producing such a signal. This creates a direct conflict with theory, because if the models are correct, the signal should not exist, and yet it does. There is also a deeper issue that scientists rarely talk about outside research circles. Most theories in physics are built to explain what has already been observed. They are extremely powerful within those limits. But when something appears outside that range, the theories do not always fail in a dramatic way. Sometimes they simply become silent. They offer no answer. That is happening here. The equations that describe stellar behavior, electromagnetic radiation, and cosmic evolution do not predict this kind of signal from this kind of environment. There is no clear pathway that leads from known conditions to this result. This forces a difficult question. Is the signal an extreme version of something we already know, pushed beyond its usual limits? Or is it evidence of something entirely new? There are hints that it might be the second option. Some researchers have pointed out that the signal shows signs of coherence. That means the waves are aligned in a way that suggests an organized emission process. This is rare in natural astrophysical sources at such scales. Coherent signals usually require very specific conditions or mechanisms that are not common in known cosmic objects. That detail alone is enough to unsettle assumptions, because it suggests that the source is not just powerful, it is structured. And structure implies rules that we may not yet understand. If that is true, then the problem is not just about identifying a new object. It is about recognizing that the current framework of physics might be incomplete, not broken, but missing something important, something that only becomes visible when the universe behaves in unexpected ways. And this signal may be one of those moments where the gap begins to show. Scientists did not accept the mystery without a fight. They began with the most familiar explanation. Neutron stars, these objects are already extreme. They are the collapsed cores of massive stars. A single teaspoon of their material would weigh billions of tons. Many of them spin rapidly and emit beams of radiation. These are pulsars, some of the most reliable clocks in the universe. At first, the signal seemed close to that idea, a repeating pulse, a distant source, strong radio emission. But the details did not match. Pulsars follow strict timing. Their rotation is stable, even tiny. Variations can be measured and predicted. This signal did not behave that way. The intervals shifted in a way that did not align with a spinning object. It was not chaotic, but it was not precise either. There was another problem: energy. For a neutron star to produce a signal this strong across such a distance, it would need to release energy at a level that stretches known limits. Some neutron stars, called magnators, are even more powerful. They have magnetic fields trillions of times stronger than Earth. They can produce sudden bursts of energy that outshine entire galaxies for a brief moment. Magnators were considered seriously, but their signals are violent and irregular. They erupt and fade. They do not create stable, repeating patterns over time. The signal being studied showed persistence. It kept returning. That is not how magnetors behave. Next came black holes. Black holes can generate enormous energy through the matter that falls into them. Some create jets that travel near the speed of light. These jets can be detected across vast distances. In some cases, they flicker or vary in brightness. But again, the pattern did not fit. Black hole emissions are messy. They fluctuate in complex ways. They do not produce clean, isolated pulses with a repeating structure. There is also the issue of location. There is no clear evidence of an active black hole in the region where the signal originates. That leaves a gap. A powerful source is required, but none is visible. Another idea pushed the boundary further. An entirely new type of cosmic object, something not yet classified. This is not as strange as it sounds. In the past, many objects were discovered before they were understood. Pulsars themselves were once a mystery. When they were first detected, their signals were so regular that some scientists considered the possibility of artificial origin. They even labeled them as little green men signals in early notes. But those were quickly explained by rotating neutron stars. This time, the situation is different. Every known category has been tested against the data, and everyone fails in some way. There are also subtle details that make the mystery deeper. The signal shows signs of coherence, which suggests a highly organized emission process. Most natural sources at this scale produce incoherent radiation, where waves are scattered and mixed. Coherent signals require specific conditions that are rare and difficult to maintain over time. This raises an uncomfortable possibility. The source might operate under physical conditions that are not fully understood, or it might involve processes that current models do not include. Each explanation gets close, but none fully works. Neutron stars explain repetition, but not the pattern. Magnetors explain power, but not stability. Black holes explain energy, but not structure. New objects explain mystery, but offer no mechanism. Every path leads to a wall. And behind that wall there is still a signal repeating in the dark. This is where the discovery stops being just a mystery. It becomes a warning. Because when a signal refuses to fit into known physics, it forces scientists to look beyond the edges of current theory. Not to replace everything, but to question what might be missing. One possibility is new forms of matter. Most of the universe is already unknown. Ordinary matter, the kind that makes up stars, planets, and people, accounts for only a small fraction of what exists. The rest is dark matter and dark energy, invisible, undetected directly, inferred only through their effects. That alone shows how incomplete the picture is. If this signal is connected to something beyond ordinary matter, it could be interacting with fields or particles that have not yet been observed. It might be using mechanisms that current instruments are not designed to detect fully. The signal itself could be the only visible trace of something much larger and more complex. There is also the question of energy. Known processes convert energy in predictable ways. Nuclear fusion powers stars. Gravitational collapse releases heat and radiation. Magnetic fields can accelerate particles. But this signal suggests a level of control and focus that does not match these natural processes. That raises the idea of unknown energy systems. Not artificial in the sense people often think, but natural processes that operate under conditions not yet understood. Conditions that may only exist in rare environments, far beyond current observation. Then there is space-time itself. Physics treats space and time as a connected fabric. It bends under gravity. It expands as the universe grows. These ideas have been tested and confirmed in many ways. but they are not complete. At very large scales and very small scales, the rules begin to break down. This signal might be interacting with space-time in a way that produces effects we do not fully recognize. Some theories suggest that under extreme conditions, space-time can behave in unusual ways. It can stretch, twist, or even form structures that influence how energy moves. If the source of the signal exists in such an environment, the signal we detect could be distorted, amplified, or reshaped by the fabric of space itself. That would explain why it looks both structured and unfamiliar. Physicists like Brian Greene have long argued that the universe operates on layers. The surface layer is what we observe directly. Beneath that are deeper levels of reality described by theories like quantum mechanics and string theory. These layers are not fully connected in current models. There are gaps, areas where the math works, but the physical interpretation remains unclear. This signal may be coming from one of those gaps, a place where known physics overlaps with something deeper. There is also a lesser-known fact about scientific progress. Major breakthroughs often begin with anomalies, small signals that do not fit, data. Points that seem like errors until they are confirmed. The discovery of cosmic background radiation began as noise in a radio antenna. The expansion of the universe was once an unexpected observation. In each case, the universe revealed something new through something unexpected. This feels similar, not because it proves a new theory, but because it exposes a limitation. It shows that there are behaviors in the universe that current models do not predict. That alone is enough to change the direction of research. It pushes scientists to build new tools, to ask new questions, to explore ideas that were once considered too speculative. And as this signal continues to repeat, it keeps sending the same message. There is more to the universe than what is currently understood. This signal may not be alone. That is the part that changes everything. For decades, the universe has been observed through limited tools. Even the most advanced telescopes could only capture a small fraction of what is actually out there. Large portions of the sky remained silent, not because nothing was happening, but because the signals were too weak, too distant, or too unfamiliar to be recognized. That is now changing. Modern instruments are reaching a new level of sensitivity. They can detect smaller variations, fainter signals, shorter bursts. Patterns that would have been lost in noise just a few years ago are now being captured and stored. And when the data improves, the universe starts to look different. There is a lesser-known detail about astronomical data. Most discoveries are not made by looking at the sky in real time. They are found later, hidden inside massive data sets. Signals can exist for years before anyone notices them. Once a new pattern is identified, scientists go back and search through old data. Sometimes they find that the same signal was already there, waiting to be recognized. That may be happening now. If one unexplained signal exists, there is a strong chance that more are already recorded, unidentified, unclassified, ignored because they did not fit existing categories. This suggests something deeper. The universe may not be quiet in the way we once believed. It may be active in ways that current models do not account for. Subtle processes, rare events, unknown objects, all producing signals that are just now becoming visible as technology improves. There is also a shift happening in how scientists approach these discoveries. In the past, anomalies were often dismissed quickly. If something did not fit, the first assumption was error, instrument failure, data corruption. That approach worked when tools were limited and false signals were common. But now, repeated anomalies are harder to ignore. When a signal appears again and again across different systems under different conditions, it demands attention. It forces researchers to consider the possibility that the anomaly is real. And that leads to a larger realization. Human understanding of the universe is still in an early stage. The laws of physics are powerful, but they are not complete. They describe many things with great accuracy, but they also leave gaps. Those gaps are usually hidden because most observations fall within expected ranges. Signals like this push beyond those ranges. They expose the edges of knowledge. There is also a psychological effect that is rarely discussed. Predictability creates comfort. The idea that the universe follows clear rules makes it easier to study, easier to explain. But when something appears that breaks those expectations, it introduces uncertainty. It shows that reality may not be as stable or as fully understood as it seems. That is what makes this discovery unsettling. Not just because it is strange, but because it suggests that there may be entire categories of phenomena that have not yet been discovered. And if that is true, then the sky is not just a map of known objects. It is a field of hidden signals, waiting to be found, waiting to be understood. And as instruments continue to improve, more of those signals may begin to appear, each one adding pressure to a system of knowledge that is still trying to keep up. A signal came from deep space. It repeats. It carries energy that should not behave this way. It comes from a place where nothing like this is expected to exist. And even after careful study, it still does not fit. That is the core of this mystery. Not just that something strange was detected, but that it refuses to be explained by the rules we trust. Every known model falls short. Every familiar object fails to match. The signal remains steady and real while the explanations fall apart around it. This changes how we see the universe. It reminds us that what we understand is only a small part of a much larger system. The laws of physics work, but only within the limits we have explored. Beyond that, there are gaps, areas where reality behaves in ways that feel unfamiliar and unexpected. This signal exists in one of those gaps. It is a quiet message from a distant part of the universe showing that there is still more to learn, more to discover, more to question. It makes even the most advanced knowledge feel incomplete, and that is not a weakness. That is where progress begins. Every major breakthrough in science started with something that did not make sense, something that forced people to look deeper, to think differently, to challenge what they believed was settled. This may be one of those moments. A small signal traveling across billions of light years, carrying a mystery that could lead to something much bigger. Because the universe is not finished revealing itself. It is still active, still complex, still holding secrets in places we once thought were empty. If this kind of discovery interests you and you want to explore more mysteries like this, take a moment to like the video and subscribe to the channel. There is a lot more out there, and we are only just starting to notice it.